Hello, Warhawks. This is Mr. Tipton. This is the first installment of Carnegie Math Geometry here at Seminole High School for the year. And I already apologize for the length of this video, the length of the notes. This is a long section compared to most sections in the book in geometry, but it's very imperative that we lay a good foundation for the rest of geometry, because the things we're going to talk about today, points, lines, planes, line segments, and rays, lay the foundation for everything in geometry. All the shapes that we're going to talk about are formed by these geometric figures. So we'll just get started here, talking about a point. A point names a location in space. Something that's tough for students sometimes is that a point has no size or shape. It's literally just a name. So here we see 3 points. I have point A, point B, and point W. So there you can see points can be anywhere. It just names a location. It's giving you a way to identify a certain location in space. Points can be used to connect each other, and they can form lines. So a line or lines connects two or more points, extends infinitely. That's a hard thing to grasp, because something that goes on forever, our minds really can't comprehend that. However, theoretically, a line extends forever in one or two directions, opposite directions, and it can't be measured because it goes on forever. Points that are on the same line are collinear. That means on the same line. If you think about playing a video game, if you're playing cooperative mode, that means you're together. So collinear just means the same line. You know, if you're playing in cooperative mode or you're cooperating, you're on the same team. Points that are not on the same line are non-collinear. However, any 2 points can be formed or can form a collinear points, because they can all make a line. So here I see 2 different lines. Well, this gets complicated because the naming of these lines. But we want to remember that we only name a line with 2 points. So here I see this line right here. So I'm going to call that line right there, I'm going to call that line D. I'm going to call that line DE. Now, to show that it's a line, I'm going to put a line above it with 2 arrows on the end, showing that it is a line. It does extend forever. Now, the common thing here is that kids want to call this line DCE. And that's actually going to be incorrect, because we only name a line with 2 of the points. So we don't want to name a line with 3 points. Now, it can be any 2 points. So not only could I call this line DE, I could also call it line CE. Or for that matter, I could call it line EC. Both of those are going to be naming the same line, because whether I'm talking about the line that's CE or EC, it's still the same line. So this line right here actually has 4 collinear points that I've named on it. So I could call this line anything with those 4 points, any combination, but I only want to use 2 of those letters. So I could call it line CF. Or I could even call it line FA. Those are referring to the same line. It doesn't matter which 2 points I use. I just don't want to call this line ACBF. You only name it with 2 points. Similar to a line, we get to something that's called a line segment. A line segment, however, has a beginning and an end. It can actually be measured with a ruler, but it's named by its 2 endpoints. So you want to be specific. You say where it starts and where it stops. So here, think about how many line segments do you actually see here. Most people would say 2, but if I look carefully, I can see that there's really 3 line segments here. There's line segment B, A, which is just this line segment here. There's also line segment AC, or I could call that line segment CA, it doesn't matter. And then you see the big line segment here, which would be the whole thing, which we would call line segment BC, or actually we could even call it line segment CB. But usually we call it BC because we read left to right. However, it really doesn't matter. So there's your 3 line segments. But I can see when I say BA, it starts at B and stops at A. Is there more there? Yes. But if I'm just talking about that line segment right there, I call it BA, or I could call it AB. This section right here is just referring to AC. This whole section here, BC, even though there's a point there, if I want to talk about line segment BC, that whole measurement right there, I could say BC or CB. Now notice when I named this, I put a line segment above it. There's no arrows on the end. That's letting people know that it starts and it stops. So I'm talking about a line segment here, not a line. If I look down here, I see a line. We have line EG or ED, however you want to say it. But I can still name a line segment within that line. Maybe I'm not wanting to talk about the whole line. I just want to talk about this part right here. I would call that line segment ED. Yes, there is a line there, but if I just want to talk about that section, I could say line segment ED. Now, if I said ED, but I threw up this right here and put arrows on the end, then I would actually be talking about line ED, which would be that whole thing extending forever. So even though if it looks like a line, you can still always name line segments within that line. You're just talking about, hey, I want to talk about this part that starts here and stops there. So big takeaway here is that we want to realize that lines go on forever, but line segments are just parts of lines that have a beginning and an end, and we can actually measure those things with a ruler or using the distance formula, which we'll get to later. The next figure that we get to is rays, or R-rays. Rays have an endpoint, but then extend infinitely in one direction. Much like a sun ray. A ray of sun starts at the sun, and then it goes on forever in one direction. It has an endpoint, the sun, and then it extends, thankfully, on forever. That's why we get heat and light. Here we see that a ray is named with its endpoint first. That's very important. Now, if I look at this picture right here, you might think about how many rays do I actually see? Well, here's an endpoint at X, and it goes on forever in this direction. So that would be one ray. However, I also have another ray. If I didn't want to talk about this part, if I just wanted to start at Y, I could start at Y and be talking about ray that starts at Y and goes through Z forever. However, I could not go backwards from that. We stop at X. There's nothing behind it here. So if I said ray YX, I would be talking about a ray that started at Y and went through X forever, but there's nothing over here. So calling something ray YX would actually be incorrect because it doesn't go on infinitely in that direction. So let's think about the ways we would name this. I would name this whole thing ray X Z. Remember that I start with its endpoint, and I'm actually going to show that by drawing this symbol. The ray symbol is a line segment with an arrow only on one end. I say where it starts and which point it goes through forever. I also have another ray here, which if I started at Y, I could actually name a ray called YZ, that instead of starting at X, it starts at Y and then goes on forever. So we also have that ray right there, which I could call ray YZ. However, I don't have a ray that starts at Z and goes this way forever. And I don't have another point over here, so I couldn't say ray Z because there's no other point to name it through. Here's where students make big mistakes on this next one. I see a ray here. It starts right there and it goes through S forever. However, because of the way that it's written, most students want to write it one of two different ways. They want to write it SQ like that. However, that's incorrect because this ray does not start at S, it starts at Q. And it doesn't start at S and go through Q, it starts at Q and goes through S. So that is not a way that we want to name this. Another thing students want to do is say that it's ray Q, S, and write the ray symbol going the opposite way, or say ray SQ and write it the other way. But that's incorrect. Even though this ray is going this direction, I still want to use this form when I name it. So that again is incorrect. The only name for this ray right here is ray Q, S, and it's drawn just like that. So don't change the way that you draw your ray symbol. It's always going to go from left to right when you're actually writing the symbol for a ray. Now rays can go in any direction, but we always write the symbol that way. Here's the next part that we're talking about. Rays that are going in opposite directions form a straight line. I see a lot of different rays here. I have ray RK that starts at R and goes through K forever. I have ray KR that starts at K and goes through R forever. I have ray WR and WK. But if we're talking about opposite rays, we want to talk about ones that actually meet, they share an endpoint, and then they go on forever in opposite directions, as you can see here. So a set of opposite rays would be these two. So I'm going to go ahead and just write this down real quick. But I said ray WR, so I still name it like that. W through R forever, starting at W. And ray WK, starting at W and going through K forever, are opposite rays. And you can see that they actually form a straight line. W would be the endpoint for both of those two rays. All right, hope I haven't lost you yet. We just got a little bit left. As we continue on, now we want to talk about planes. Now this is a hard thing to grasp because we really don't have something like this in our real world. So for a plane, you have to imagine maybe a piece of paper that extends forever. I know that's hard to wrap your mind around, but a plane is just a flat surface. It's two-dimensional, but it extends forever. So imagine that piece of paper just growing and growing and growing and getting larger, but then eventually just going on forever, having no beginning or end. Planes are named with a combination of any 3 points that are on the same plane. These are called coplanar points. Much like collinear means the same line, coplanar means they're on the same plane. Just like writing 3 or 4 dots on your paper, those are on the same flat surface. If we'll get to this part in a second, but if 2 planes intersect, they intersect along a line. So here I see 4 points that are on this flat surface. Now it's hard to draw a plane so that you can see it, but imagine this is a flat surface that extends actually forever in all those directions. It never stops. Okay, so we're extending out here forever. But here we see 4 points that are on it. I don't have to use more than 3 points. I just use 3 points. So I could call this a bunch of different things. I could call it plane AWC. I could call it plane GWA. I could call it plane WCA. Any combination of those 3 letters, because they're on the same plane, will identify that plane. Okay, you don't want to use 4 letters, and you want to make sure that you use 3 letters that are on the same, or 3 points that are on the same plane. Now we get to that last part. Where planes intersect is actually along a line. Now I can see where these 2 planes, I've got this plane that's going this direction, and I've got this plane that's going this direction, but they intersect right here. Now it looks like they intersect along a line segment right there, AB. But remember that planes go on forever. So even though we can't really draw it, these two figures are actually extending in directions forever. So when they touch along actually line AB or line BA. Hopefully you can understand that, but these are infinite, so they go on forever. Also, we get to another point here. We get to something that's called skew lines. You've probably heard of parallel lines before. Parallel lines are lines that never touch. But much like never touching, you kind of think about lines that are like, let's see, lines that are like this, that run side by side. They never get any closer or further apart, and they never touch. But we also have something that's called skew lines. Now imagine with me, if you will, that we have a line right here extending like this forever, and we have a line right here extending through in forever in that plane. Now think about this. This line's up here, and this line's down here. But they're never going to touch. However, they're not parallel lines. So we want to say that skew lines are actually lines that are in different planes but still never touch. They're not parallel. So skew lines are lines that never intersect, which means touch, but are in different planes. We can see that these two lines, this line is part of plane QAP. This line, however, is part of plane MAN, but they're never going to touch. All right, I hope you enjoyed that, and we'll see you in class. Sorry about the length of that video.